Welcome to Teolumen Insights, where we reveal the hidden forces that shape the way you live and show you how to use them to create real transformation and supercharge your health, mindset, and daily life. Here are your hosts, Emma Greenwood and Nathan Sinclaire.
Hello and welcome to Teolumen Insights. I'm Nathan.
And I'm Emma.
So today we're going to dive deep into something pretty wild. We're calling this one Becoming Timefaring. Informational time travel.
Yeah, buckle up.
I think when people hear time travel, they often picture, like Marty McFly in Back to the Future or some crazy paradox where you meet your past self.
Exactly.
But what we're looking at today is something much more grounded in, well, as grounded as it can be, I guess, in actual science and the potential of future tech. We're talking about communicating across time, sending information, messages, data back and forth through time. What do you think? I mean, when you think about time travel, what kind of images pop into your head?
Well, it's funny you should say that because I think a lot of people, and certainly myself included, immediately go to this place of tangled timelines and the risks of accidentally erasing yourself from existence. You go back and you step on a butterfly and suddenly the world's completely different.
Right.
But what if that picture, those images are fundamentally flawed?
Yeah.
What if the universe has this kind of built-in mechanism for temporal harmony, and that's what we're going to be exploring today.
Yeah.
We're going to be looking at all those classic paradoxes and hopefully revealing a potentially far more consistent and liberating reality of time interaction. Definitely.
I think that's the most fascinating part of all this research is that it starts to change the way that you feel about time itself.
Yeah.
It becomes this thing that isn't as scary and fragile as maybe some of the science fiction that we've consumed has led us to believe.
Right.
So to kind of lay out the map for our Dirty Today, we've got 5 parts to this deep dive.
Yeah.
First, we're going to be talking about debunking time paradox myths from science fiction.
Yes.
And in particular, we're going to be looking at the big one, the grandfather paradox.
Right.
And then we're going to move into presenting this alternative of a self-consistent universe.
Yeah.
And I think that that's probably the most interesting part. So when things start to click a little bit, we'll see how that goes.
Yeah.
After that, we're going to step back a little bit. We're going to compare the shift in thinking about time to other paradigm shifts throughout history.
Oh, interesting.
And we're gonna try and show how humans have a history of kind of getting things wrong at first.
Yeah.
Especially when it comes to big concepts like this.
For sure.
We're gonna peek into some quantum evidence.
Ooh.
I know that's your favorite.
My favorite.
But we're gonna try and explain it simply.
Simply. Okay, we'll see.
In a way that hopefully won't require a physics degree to understand.
Challenge accepted.
And then finally, we're going to envision a future populated by Timefarers.
I like this.
And we'll kind of see where that takes us. So before we jump into all that, if you are enjoying this deep dive into these fascinating ideas, please hit that like and subscribe button.
Yeah, that'd be great.
It helps us to keep bringing you this kind of content.
Yes, please.
All right, so let's dive into those time paradox myths from science fiction.
Yes, let's do it.
I mean, it's amazing to me how our understanding of time travel, even just in the general public, how much it's been shaped by the things that we've seen in movies and read in books.
Oh, absolutely. I mean, I think science fiction has this incredible power to shape our understanding of not only what's possible, but maybe even what's desirable. And I think it's done, it's had a huge impact on how we view time travel.
Totally. And one of the things that it's done, one of the tropes that it's introduced that is, it just seems to stick around, is this idea of time as this unbelievably fragile thing.
Right.
Like this delicate spider web. Do you remember that story, Sound of Thunder by Ray Bradbury?
Yes, classic.
Where they have those dinosaur hunters have that assigned walkway.
Right.
That they have to stick to so that they don't disturb anything.
Right. I love that story.
Yeah, and the idea is that even just step on a butterfly millions of years in the past could have these huge repercussions in the present.
Right.
That time is just a house of cards waiting to fall apart.
Right. And it's a vivid analogy, isn't it? I mean, it really captures this kind of underlying anxiety that we have about the past.
Yeah.
That any kind of meddling could just unravel the present.
Exactly.
And I think in many ways that anxiety is a direct legacy of the grandfather paradox.
Oh, the grandfather paradox.
Yes.
The big one?
The big one.
It seems to rear its head in almost every time travel discussion.
It really does. I mean, I can't think of a science fiction story that I've seen that involves time travel where it doesn't at least try to address this.
Right. And it's become part of our cultural understanding, you know, and I think it's interesting because it speaks to this deep fear that we have of disrupting the natural order of things. Totally. Yeah. So for anyone who hasn't wrestled with this paradox in their minds, what is the grandfather paradox and where did it come from?
So the term itself kind of gained traction with a 1929 editorial by Hugo Gernsback, who is really a real pioneer of science fiction.
Right.
And he posed this thought experiment. What if a time traveler went back and prevented their own grandfather from meeting their grandmother?
Okay.
And so, you know, logically then their parent wouldn't be born, therefore they wouldn't be born.
Right.
So therefore the time journey itself wouldn't be possible. It's this neat self-contained loop.
Right.
It's a logical loop that seems to tie the possibility of altering the past in knots.
Yeah.
And it's been used, you know, as you say, it's become part of popular culture, hasn't it?
It really has. One of the first examples that comes to my mind is Back to the Future.
Yes.
Which is very much fueled by Marty McFly trying to make sure his parents get together, you know, or he's going to fade out of existence or, you know, whatever the outcome's going to be.
Right, right.
But even in more recent, like the most recent Indiana Jones film, there's this fear of mucking up the timeline.
Yes.
You know, if they stay in the past too long or do something they shouldn't.
Right. It's like this deeply ingrained assumption that the past is just waiting for us to sneeze on it.
Right.
And it'll rewrite itself into something unrecognizable.
Yeah, like it's this fragile thing that we could so easily destroy.
Yes, exactly.
But that's where it gets interesting when you really start to pick these paradox narratives apart.
Yeah.
They often fall apart into their own weight, don't they?
They really do. And one of the sources that you shared pointed to that Star Trek episode, The City on the Edge of Forever.
Yeah, great episode.
A classic. You know, where Dr. McCoy steps through the Guardian of Forever, the time portal.
Yeah.
And suddenly the whole timeline's altered. The Enterprise never existed.
Yeah, right.
But hold on a minute. If the Enterprise never existed, how did Kirk and Spock and the landing party even get to that planet in the first place?
Yeah.
You know, it's like the story's premise contradicts its own outcome.
It does. It pulls the rug out from under itself. And the same kind of logical flaw pops up in other time travel stories too, like in Bradbury's story.
Right.
If Eccles stepping on that butterfly really did change history so drastically that a fascist regime took over.
Right.
Well, wouldn't those time travelers themselves be products of that altered reality?
Precisely.
You know, how would they even know that things were different?
Right.
Their memories, their entire understanding of history would be shaped by this new past.
It's like the ultimate Mandela effect.
Right.
You know, this collective misremembering of events.
Yes.
But amplified to a universe-altering scale.
Right. And so it doesn't make sense. And I think the takeaway from this is that while science fiction has done a fantastic job of capturing our imaginations when it comes to space exploration, when it comes to other worlds,
right,
it may have inadvertently created what Eric Wargo calls an imagination problem.
Yes.
When it comes to time travel.
Absolutely.
You know, this focus on preventing these paradoxes may actually be blinding us to the true nature of time.
Absolutely. And I think Wargo's point is that, you know, we're so busy looking for the temporal boogeyman that we might be missing a potentially much more fascinating and consistent landscape.
Right. So we've got all these fictional portrayals that have led us down these paradox-ridden paths.
Right, right.
What's a more, I don't know, coherent, a less anxiety-inducing way to think about interacting with time?
Right.
And that brings us to part 2, where we're going to present this alternative of a self-consistent universe.
Yeah, I like that.
And one of the things that Eric Wargo says that I thought was really insightful was he said that this idea that we have of causality,
yeah,
where one event neatly leads to another, like dominoes.
Right.
He calls that folk causality.
I love that folk causality.
Yeah, he says that it might be just a way that our culture has taught us to understand the world, but it might not be the true underlying principle of the universe itself.
Right.
It's just a useful everyday way to think about things.
Right, exactly. And I think building on that, Paul Nahin, whose work you also shared, he makes this really crucial distinction between influencing the past and actually changing it.
Okay.
So think about it this way. Everything you do in the present has consequences for the future, right?
Right.
Yeah? Your choices shape what comes next.
Yeah.
Now, if time travel were possible, any actions that a time traveler took in the past would similarly have effects.
Yeah.
They would become part of the tapestry of history. But that doesn't mean they're retroactively rewriting a pre-existing script.
Right.
Their actions are part of the unfolding story, just as yours are in your present.
Okay, so the universe is not some, fragile screenplay
Right.
that we can edit with a temporal pen.
Not according to this perspective.
Right.
The universe, in a sense, can't be fooled.
Right.
All actions, including those of a time traveler, are already woven into the fabric of space-time.
Okay.
Even our feeling of free will, the choices you make every day, are part of that unfolding process.
So it's more like a river.
Yeah, I was just thinking that. It's like you can splash around and influence the currents, but
Right.
you can't suddenly make the water flow uphill.
Right. Okay, that's a great analogy.
Yeah.
So if we can't actually change the past, what happens if a time traveler tries to do something that is inherently paradoxical?
Right.
To prevent their own birth.
Well, that's where this concept of it can't happen because it didn't comes into play.
Right.
It's almost a temporal Zen koan, if you will.
I like it.
It's a fundamental principle of temporal consistency. Events that we label as paradoxes simply lack the necessary prior history to occur.
Okay.
So it's like trying to build a skyscraper out of toothpicks.
Yeah.
The structural integrity just isn't there. Or, to use another analogy, it's like trying to attend your own funeral.
Right.
The prerequisite for being there is that you're alive, which contradicts the very event.
Yeah, that makes sense. So attempting a paradox, it's not gonna unravel the universe.
No.
It's just not gonna happen.
It's just not a viable course of action.
Right. The universe will self-correct, or it'll prevent the paradoxical event from happening in the first place.
Precisely. And there's some fascinating theoretical work that supports this idea of self-correction. There's a physicist named Igor Novikov who proposed this thought experiment involving a billiard ball traveling back in time through a wormhole,
Okay.
attempting to collide with its earlier self and prevent it from entering the wormhole.
So a paradox.
A classic paradox, yeah. And his calculations showed that any such attempt would result in this glancing blow,
Oh, okay.
this slight nudge that alters the ball's trajectory in a way that maintains a consistent timeline. So the paradox is avoided by the very physics of the interaction.
That's fascinating. So it's like the universe has its own, temporal immune system or something.
Exactly.
It deflects these paradoxical infections.
Exactly. And Kip Thorne, who's a really towering figure in black hole research.
Yeah.
He and his students further developed and confirmed Novikov's thinking.
Okay.
Even more recently, Seth Lloyd at MIT conducted this really intriguing experiment with photons, those fundamental particles of light,
Yeah.
where a photon essentially interacted with its past self. And again, the results pointed towards self-consistency. As Lloyd kind of humorously put it, grandfathers and past selves are tough customers to eliminate.
That's great. So all those dramatic science fiction scenarios that we've seen where timelines are fracturing with the slightest temporal hiccup
Right.
are probably wildly inaccurate.
It seems so.
This self-consistency view paints a very different picture
Yeah.
of time as something far more resilient and, in a strange way, logical.
Yeah, I think that's right. I mean, it's almost like, time has its own internal logic.
Yeah.
And it's a logic that we're only just beginning to understand.
Yeah. Which brings us to this third part, which is looking at how this shift in thinking about time echoes some of the other major paradigm shifts in the history of science.
Oh, interesting. Okay.
So I think it's really important to remember that even brilliant minds can be constrained by their existing understanding when they're faced with a truly novel idea.
Oh, absolutely. I mean, think about the 15th century and Filippo Brunelleschi, who did this groundbreaking work on linear perspective in art.
Yeah.
So he developed this revolutionary technique for creating the illusion of depth on a flat surface.
Right.
He even built a demonstration of the Florence Baptistery that was incredibly realistic. But here's the fascinating part. Even Leonardo da Vinci, a true visionary,
Yeah.
initially believed that this effect could only be experienced under very, very specific, almost artificial conditions. You had to look through this tiny peephole with one eye fixed at a precise viewpoint.
A peephole.
Yeah, a peephole.
That's so limiting. Why would they think that?
Well, it seems that Brunelleschi himself emphasized this single station point for the viewer's eye to accurately perceive the illusion.
Right.
And Leonardo, who was, deeply impressed by this new technique, he kind of took that limitation as gospel.
Wow.
He even wrote that if, multiple people tried to view a perspective drawing simultaneously, they would just see a distorted mess. Really? He couldn't quite grasp how those principles could apply more broadly.
That's so interesting because
Yeah.
today we look at perspective drawings all the time.
Exactly.
We look at photographs, even virtual reality, and we don't need a peephole.
No.
It's become so fundamental to our visual language.
Exactly. It's second nature to us.
Yeah, that we don't even register it as an illusion anymore.
Right, exactly. And so 600 years ago, even the greatest minds were imposing these unnecessary restrictions on this transformative idea.
Yeah.
And that's where I think the parallel to our current understanding of time travel becomes so interesting.
Right.
Because right now we're kind of in this early stage of grappling with the fourth dimension.
Yeah.
We have this wealth of captivating stories and thought experiments,
Yeah.
but they often confine us to those restrictive assigned walkways,
Yeah.
largely due to this fear of paradoxes.
So Stephen Hawking, who we mentioned earlier, he famously dismissed the possibility of time travel because of the potential for these paradoxes.
Right.
He's almost like Leonardo insisting on the people for perspective.
Absolutely. It's like, he couldn't see beyond the potential for chaos and disruption.
Right. He even proposed his chronology protection conjecture.
Yes.
This idea that some law of physics prevents time travel just to avoid those messy causal violations.
Exactly. It's like imagining a temporal police force
Right.
enforcing the laws of causality.
Yeah, it's a funny image, isn't it?
It is.
But the point is that just as we moved beyond this peephole view of perspective and recognized its broader applicability, we need to do the same with time travel.
Absolutely.
We're looking at it through this very narrow lens right now.
Right. And it's all about overcoming those initial, often flawed assumptions.
Exactly. Which brings us to part 4. We're going to try to dip our toes into quantum evidence.
Oh, here we go.
So quantum physics has this reputation for being wonderfully weird.
Oh, yeah.
So how does it shed light on this idea of a self-consistent timeline?
So, while we might not have gleaming time machines parked in our garages just yet,
Right.
there's some really, really fascinating research happening at the quantum level
Okay.
that offers these intriguing hints about the possibility of interacting with time in ways that just really challenge our classical intuitions.
Okay.
There's even this theoretical work being done on what you might call quantum chronophones.
Quantum chronophones.
Yes. Essentially, you can think of them as devices that could potentially enable informational time travel.
Informational time travel.
Yeah.
Okay, so we're talking about sending a message to the future
Yeah.
or receiving information from the past using quantum phenomena.
It's like a quantum telegram.
That's amazing.
Yeah.
But how does that relate to this idea of self-consistency that we've been talking about?
So those quantum experiments we touched on earlier, like Seth Lloyd's work with the photon interacting with its past self,
Right.
they provide this glimpse into how the universe seems to maintain coherence even at the most fundamental scales.
Oh.
At those probabilistic scales where quantum mechanics operates.
Right.
And if these underlying principles of self-consistency are kind of operating at that quantum level, it suggests that similar principles might govern larger scale temporal interactions.
So it's almost like saying that the universe has this preference for being logically consistent.
Yes, exactly.
No matter what the scale.
Exactly.
Whether it's, a photon interacting with its past self or a person traveling through time.
You're right.
The same principles apply.
It's a fascinating idea, isn't it?
It is. So while the idea of a future with Timefarers might sound totally surreal to us, especially given, our ingrained fear of these paradoxes,
Right.
the mechanisms that might make it possible, they could already be at play
Yeah.
in the quantum realm.
Exactly. And surreal doesn't necessarily mean impossible.
Right.
It just means wildly different from our everyday experience.
Yeah.
It's a hint of realities that we haven't yet fully grasped.
That's a good way to put it. And that brings us to our fifth and final part,
Oh.
where we're going to envision this future populated by these so-called timefarers.
Yes.
So we've talked about, one-way trips to the future
Right.
via relativistic effects or suspended animation, that kind of thing.
Right.
But what does true timefaring really entail?
So we're talking about the potential to consciously navigate the temporal landscape,
Okay.
to move both forward and backward from our present moment,
Right.
and hopefully with the ability to return.
Right. It's going to be a round trip.
Yeah, it's got to be a round trip. And it also opens up this possibility of two-way communication across time,
Right.
not just passively observing echoes of the past or hoping for signals from the future, but actually engaging in dialogue.
Yeah. Okay, so what would drive this kind of temporal exploration? Why would we want to do this?
Well, I mean, the motivations could be incredibly diverse.
Yeah.
Imagine the potential for accessing lost knowledge, for retrieving resources or information from the past that's no longer available.
Yeah, I mean that would be huge.
Huge.
Yeah. Just being able to go back and get things that we've lost.
Exactly. Some people even speculate about the possibility of what we might call history gardening.
History gardening.
Yeah, the idea of subtly guiding the trajectory of civilization by nudging events in the past towards a more beneficial future.
That's a really interesting idea.
It is. It's a bit of a mind bender, though, isn't it?
It is. Yeah, but it's also potentially very dangerous.
Oh, absolutely. And that's where, some of your sources touch upon this. The more cautionary possibility of transtemporal colonialism,
Right.
Exploiting the past for present gain in potentially harmful ways.
Yeah.
So that's a serious ethical consideration that any time-faring civilization would have to grapple with.
Yeah, absolutely. So if we are going to become timefarers, what kind of being is equipped to deal with this?
Right.
You use the term Homo chrononauticus.
Yes, I like that.
What does that mean?
So I'm drawing a parallel here to Jacques Cousteau's concept of Homo aquaticus, humans adapted to the ocean.
Right.
But for timefarers, the primary adaptation might not be so much biological,
Okay.
but rather cognitive and societal.
Okay.
It's about a fundamental shift in our understanding of time itself.
Okay.
So the ingrained fear of paradoxes, the notion that we could unravel the fabric of reality.
Right.
By interacting with the past, that would likely fade. As we develop this deeper appreciation for time's inherent self-consistency.
So a civilization that's mastered time travel would also have to master its anxieties about the past.
Precisely.
Yeah.
And I think that's really the crucial step before we become truly time-faring.
Right.
It's about cultivating a culture where the past is viewed as this rich and interconnected landscape to be explored.
Yeah.
Not a delicate artifact to be feared.
So it's about changing the way that we feel about time.
Absolutely. And I think that a universe that includes the possibility of time travel is inherently more complex and frankly more interesting than one rigidly confined by linear time and the constant anxiety of paradoxes.
Yeah.
And the very fact that our present doesn't feel overwhelmingly chaotic and paradoxical might even suggest that we're on the cusp of this time-faring future.
That's a great point.
We're poised to shed our temporal anxieties and embrace a more nuanced understanding of time itself. And if you're finding these explorations into the less traveled paths of knowledge as fascinating as we do, please take a moment to hit that like button and subscribe. It helps us keep bringing these deep dives to you.
All right.
Let's start with something that sounds like pure science fiction, but might actually have some surprising roots.
Okay.
Quantum retrocausation. For most of us, it's simple. What happened before causes what happens now. Yeah. But quantum physics seems to be hinting at something much more intricate.
That's right. Our everyday experience tells us about a straightforward flow of cause and effect. A leads to B.
Right.
But when we peer into the quantum realm, the rules start to get? Well, less like rules and more like suggestions.
Okay.
Quantum retrocausation is the idea that under certain conditions, events in the future can actually have an influence on what happened in the past, at least at the level of fundamental particles.
Future influencing the past. That sounds like a paradox waiting to happen. How can something that hasn't occurred yet possibly affect something that already has?
It really challenges our fundamental intuitions about time.
For sure.
Think about a quantum particle before it's measured. It exists in a state we call superposition, which is a bit like saying it's in multiple states at once.
Right.
It doesn't have a definite position or momentum. Now, imagine a lottery ticket before the numbers are drawn.
Okay.
It holds the potential to be a winner or loser. But its state isn't fixed until the draw happens, a future event, relative to the ticket's purchase.
Gotcha.
Some interpretations of quantum mechanics suggest that the act of measuring a particle in the future is akin to drawing those lottery numbers.
Interesting.
It's the future interaction that seems to retroactively define the particle's state in the past, selecting one possibility from that superposition of potential states.
Wow.
What's fascinating here is that it challenges our fundamental assumption that reality exists in a definite state independent of observation, suggesting a more participatory universe.
Okay, that lottery ticket analogy gives me a slightly less blurry picture. So the future act of measurement isn't just revealing a pre-existing state, it's somehow solidifying what that state was. That still feels incredibly strange. Is there any actual evidence that supports this mind-bending idea?
It's certainly a hotly debated topic, but there have been some intriguing experimental results that point in that direction. For instance, in 2009, researchers at the University of Rochester conducted an experiment involving laser beams. They performed a weak measurement on two identical beams, and then later subjected only one of the beams to a much stronger measurement. The surprising result was that the photons in the beam that experienced the strong future measurement appeared to have been measurably different, even during the initial weak measurement in the past. It suggested a backward flow of influence.
That's wild. It's like the future action gave those past photons an extra something. Were there any other experiments that hinted at this kind of backwards causality?
Yes. In 2011, a team at MIT designed a clever experiment they called a quantum gun. They used a technique called post-selection, where you essentially only look at the experimental runs that yield a specific outcome in the future. By doing this with photons, they were able to demonstrate the possibility of sending information into a photon's own past, although we're talking about incredibly tiny fractions of a second.
Wow.
It was a demonstration that information could, in a very limited way, travel backwards in time without creating paradoxes. It's like a tiny ripple in the temporal pond.
So no grandfather paradox scenarios in the quantum realm.
Not in these carefully controlled experiments. And more recently, in 2021, neuroscientist Julia Mossbridge conducted some fascinating work with variations of the classic double-slit experiment with photons.
Right.
She found that the interference patterns created by the photons seemed to change depending on the duration of the experimental trial. Essentially, the future of the photon within the experiment.
Okay.
While she couldn't definitively say it was interaction across time, it certainly opens up that possibility and suggests what she called causally ambiguous behavior.
It's almost like the photons have a sense of their future.
Yeah.
And I remember reading about an experiment out of the University of Toronto where photons passing through supercooled rubidium atoms seemed to spend a negative amount of time inside. They exited before they even appeared to have fully entered.
Exactly. These are all pieces of a puzzle that suggest our linear arrow-like perception of time might be a simplification of a much more complex underlying reality at the quantum level.
Right.
Now, if we connect this back to our focus today,
Yeah.
what's truly intriguing is the potential implication for sending information across time. If future events can influence the past at the quantum level, could we potentially harness this to send signals backwards?
Okay, my head is officially in a superposition of confusion and fascination.
Yeah.
But let's try to follow this thread. If we could somehow send information from the future to the past, what could we actually do with it?
Right.
That brings us to our second point, chronophones, and the potential for preventing disasters.
Right. This is where the theoretical starts to meet some potentially very real-world applications, or at least thought experiments about them,
Okay.
inspired by William Gibson's novel, The Peripheral. We can imagine advanced technologies, perhaps based on quantum computing, acting as interfaces,
Right.
what Gibson called chronophones or C-mail servers, for communicating across time. Now, it's important to distinguish this from the idea of branching timelines you often see in science fiction.
Okay.
The concept we're exploring here It's more towards a single self-consistent timeline.
So no going back and rewriting history as we know it.
That's the implication here. Any information sent back would have to be consistent with the history that led to that information being sent in the first place.
Okay.
It's a bit like a feedback loop that has to resolve itself without creating a paradox.
Right.
But even within those constraints, the potential for beneficial applications is tantalizing. Imagine a future where meteorologists detect a massive, unprecedented hurricane forming.
Yeah.
Using a chronophone, they could send detailed warnings back to the present, giving coastal communities crucial days or even weeks to prepare and evacuate.
That would be an absolute game changer, saving countless lives. Or think about seismologists in the future being able to accurately predict a major earthquake or tsunami and sending early warnings to help mitigate the impact.
Exactly. The possibilities extend beyond natural disasters. Consider law enforcement receiving information about an impending terror attack. They might not be able to prevent the initial conditions that led to the attack, but they could certainly use that foreknowledge to prepare a response, minimize casualties, and potentially apprehend those involved before more harm is done. This idea of using temporal communication to proactively create better outcomes in the future by influencing the past within the bounds of a self-consistent timeline has been referred to as history gardening.
History gardening, I like that. It suggests a more subtle and nurturing form of influence rather than radical alterations. You mentioned an epidemiology scenario in our notes. Can you walk us through that?
Certainly. Imagine a future where new and highly virulent pathogens are emerging at an alarming rate due to environmental changes. Using a sophisticated quantum server acting as a chronophone, researchers could potentially send detailed genetic information about these future diseases along with insights into their mechanisms and potential vulnerabilities back to the 21st century. This would give scientists in our time a significant head start in developing vaccines, antiviral drugs, and diagnostic tools so that when these diseases eventually do emerge in the future, humanity is already equipped to combat them. It's about preemptive preparation on a massive scale.
That's an incredibly hopeful vision of how this technology could be used. But you keep emphasizing this limitation about not being able to change history.
Yeah.
It feels like that significantly restricts what we could actually achieve with these chronophones.
It's a crucial point. The self-consistency principle is key.
Right.
The information sent back becomes part of the past that eventually leads to the future where the information was sent. It's a closed loop.
Okay.
So while we might receive a warning about a specific event, we couldn't necessarily send information back to prevent the underlying causes of that event. If those causes are integral to the timeline that ultimately leads to the future sender, it's a subtle but fundamental constraint.
Okay, I think I'm starting to grasp the implications of that self-consistency. It's a very different picture than the time travel we often see in fiction. But if this kind of informational time travel does become a reality, it's hard not to think about the potential for things to go wrong. That leads us to our third area. The ethical dilemmas of temporal influence.
This is where the conversation takes a sharp turn and we have to confront some potentially uncomfortable possibilities.
Yeah.
While the idea of preventing disasters is compelling, the potential for misuse of informational time travel is significant. Imagine a future where amoral corporations or governments see the past not as a shared history, but as a resource to be exploited.
That's a disturbing thought. Can you give me a specific example of what that might look like?
Think about pharmaceutical companies in the future that have developed new drugs but want to bypass rigorous testing protocols. They could potentially send information, and even the drugs themselves, back to past populations for uncontrolled experimentation with no ethical oversight or accountability to the people being used as test subjects.
Oh, well.
Or imagine defense contractors testing out advanced and devastating new weapons in the past, observing their effects without any of the modern constraints of warfare. The past could become, as some science fiction has explored, a kind of unregulated laboratory or a third world for exploitation.
It's easy to see how the temptation to gain a strategic or financial advantage would be immense. And you mentioned the likelihood of secrecy surrounding such a powerful technology.
Absolutely. Given the potential implications, both positive and negative, it's almost guaranteed that informational time travel technology would be shrouded in the deepest secrecy.
Yeah.
Think about the persistent rumors and suspicions surrounding technologies like anti-gravity or free energy.
Right.
Time travel, even in this limited informational form, would likely be the most highly classified secret imaginable, held tightly by nation-states and other powerful organizations.
And if multiple actors have access to this, you could almost envision a kind of time war playing out, not with physical battles in the past,
Right?
but with rival factions subtly trying to influence events through the information they send back, perhaps trying to nudge technological development or political outcomes in their favor.
Exactly. It would be a clandestine struggle for temporal advantage.
Wow.
And then there's a fundamental issue of trust.
Yeah.
If you receive a message claiming to be from the future, how do you verify its authenticity? How do you know who sent it and what their true motives are? Could it be a genuine warning or a sophisticated piece of disinformation designed to manipulate the present for some future gain? It raises profound questions about epistemology and trust across the vastness of time.
It sounds like a real Pandora's box of ethical and strategic complexities. It makes you wonder if the potential for good could ever truly outweigh these inherent risks.
It's a critical question we need to grapple with as we continue to explore these possibilities. And speaking of profound transformations, let's move on to our fourth point, which takes us into even more speculative territory. The idea of a super-technological singularity driven by time loops. This is where the potential for truly radical change emerges.
Okay, I'm bracing myself. A technological singularity fueled by time loops. Unpack that for us.
The core concept here is that future users of informational time travel could send back advanced technological blueprints, scientific breakthroughs, even just crucial pieces of knowledge that would otherwise take decades or centuries for us to discover independently.
Right.
This could lead to a dramatically accelerated pace of technological development, potentially allowing us to bypass entire stages of innovation. It's like a technological bootstrapping effect.
Okay.
Think about James Cameron's Terminator movies, where the creation of advanced AI in the future inadvertently leads to its own origins in the past through time travel.
Okay.
A self-feeding loop of technological advancement.
So instead of this slow, incremental process of scientific discovery, we could essentially receive a jump start from our future selves.
Precisely. However, there's a crucial limitation to consider.
Okay.
A future civilization can only send information back to a point in time after they have developed the capability for temporal communication. This creates a kind of temporal event horizon around their future technology. We can only receive information from a point in time after that chronophone or similar device has been activated.
That makes sense. It prevents infinite information loops stretching back to the dawn of time, at least initially.
Right.
But even with that limitation, the implications of this kind of technological feedback could be staggering. I remember reading about Michael P. Masters' fascinating theory that some UFO sightings could actually be future human time travelers.
Right.
How does this idea connect?
Masters proposes that these alleged future time travelers might inadvertently or even intentionally be leaving behind artifacts or exhibiting technologies that are so far beyond our current understanding that we misinterpret them as extraterrestrial in origin. This becomes particularly interesting when we consider the possibility of technological bootstrapping. Through time loops,
Yeah.
we might be encountering glimpses of our own far future technological advancements, perhaps even reverse engineering fragments of them without fully comprehending their origins.
That's a mind-bending reinterpretation of the UFO phenomenon.
It is.
It's almost like technology could spontaneously appear seemingly without the traditional groundwork of scientific progress.
Exactly. This leads to the provocative idea that informational time travel could fundamentally alter the very nature of scientific inquiry. Instead of the painstaking process of formulating hypotheses, conducting experiments and peer review that defines modern science, the secrets of the universe, might in a sense be given to us by our descendants. The TV series Dark explores similar themes of information and technology flowing through time in unexpected ways. Arthur C. Clarke famously said that any sufficiently advanced technology is indistinguishable from magic, and in this context, technology emerging from time loops might literally seem to appear spontaneously without any discernible intellectual or technical labor in our present understanding.
So we could be looking at a future where the traditional concepts of invention and work become almost obsolete due to this influx of advanced knowledge from the future. It sounds almost utopian, but also deeply strange.
It certainly raises profound questions about the future of work innovation and what it even means to be a technologically advanced civilization. Our journey towards becoming time-faring might indeed lead to a fundamentally different kind of society.
It's a truly dizzying prospect.
Okay.
After contemplating all of that, we arrive at our final point, which feels like the ultimate philosophical puzzle. Reconciling free will and predestination in a world where information can travel through time.
It is indeed the crux of the matter. If information about the future can be sent to the past, and if, as we discussed with retrocausation, the future might even influence the past at a fundamental level, What becomes of our sense of agency and the feeling that we have genuine choices? Ted Chiang's brilliant short story, What's Expected of Us, provides a powerful lens through which to examine this dilemma with the introduction of the predictor toy, a simple device that lights up a second before the user consciously presses its button.
Right, that seemingly innocuous toy that appears to show our actions before we even decide to take them. It throws our whole understanding of cause and effect into question at a very personal level.
Exactly. The predictor creates a direct experience of what seems like a predetermined future influencing the present. But it's crucial to remember the principle of the self-consistent timeline we've discussed. You cannot change what will happen. Your very act of reacting to the predictor, your desire to perhaps try and outsmart it by not pressing the button when it lights up, that is itself part of the predetermined sequence of events.
Right.
Our feeling of having a choice of being able to do something different remains a powerful and essential part of our human experience.
So our subjective experience of free will persists even within a framework where the future might, in some sense, already be written.
Precisely. Our psychological experience of agency is a fundamental aspect of being human. And as we touched on earlier, the insights of thinkers like Freud, who explored the complexities of human motivation and desire, become incredibly relevant here.
Okay.
Even if information from the future exists in the past, our interpretation and reaction to that information will be filtered through our own psychological landscape. We might misinterpret it, dismiss it, or even actively try to defy it, all of which are still part of the unfolding timeline.
It's like we're hardwired to believe in our own agency, even if the universe operates under different rules.
Precisely, Chiang's story also explores the unsettling phenomenon of akinetic mutism, where some users of the predictor, overwhelmed by the apparent lack of free will, lose their sense of agency and become passive. This highlights the potential psychological toll of confronting the possibility of retrocausation. However, it's also conceivable that as humanity evolves and potentially becomes more accustomed to the idea of temporal influences, we might adapt to these constraints, finding a way to reconcile our sense of free will with a more nuanced understanding of time.
That's a fascinating idea, a future version of ourselves, a Homo chrononauticus, who has come to terms with the complexities of time in a way we haven't yet.
Perhaps. And to navigate the complexities of transtemporal communication without succumbing to paradoxes or psychological distress, we might need to develop sophisticated mechanisms, perhaps even akin to double-blinding protocols used in scientific research, where the full context of information set across time is deliberately obscured to minimize the urge to alter events based on incomplete knowledge.
So a future where even communicating with the past or future requires careful management of our own inherent biases and the desire for control.
Indeed. But there are also more affirmative ways of approaching this. Consider Nietzsche's concept of amor fati, a love of one's fate, accepting and even embracing the totality of one's existence, including the events that are beyond our control. Or Julia Mossbridge's idea of congruence, consciously aligning oneself with their future and past, finding a sense of harmony within the flow of time. These philosophical frameworks suggest that embracing a potentially interconnected view of time might be a path to navigating a time-faring reality without the anxieties of perceived lost free will.
It's almost as if the predictor toy and the very concept of informational time travel could act as a kind of physical co-in, as we noted, a paradoxical puzzle that forces us to confront our deepest assumptions about causality and agency, potentially leading to a profound shift in our understanding, a kind of intellectualisatory.
Exactly.
Yeah.
The initial disorientation and even the akinetic mutism seen in Chiang's story might just be a stage in our evolution as we grapple with these concepts, eventually leading to a more integrated and perhaps even more accepting understanding of our place within the tapestry of time. Wormholes.
Right, wormholes.
So Emma, can you break down wormholes for us? Like, what are we even talking about here?
Okay, so imagine space-time. It's not just a backdrop, right? It's like this fabric, this active participant that can be warped and twisted by mass and energy. Wormholes, they're like extreme bends in that fabric.
Hands.
Yeah, bends, like folds, creating shortcuts between two really distant points. And it's not just space, right? We could be talking about huge stretches of time, too.
Whoa! So not just zipping across galaxies, but jumping to, I don't know, the dinosaurs or something.
Exactly. It sounds crazy, but there's actually some real science behind this. It goes back to Einstein and his theories of relativity.
Einstein, of course. So how does his work tie into these wrinkles in time? Well, Einstein showed us that gravity isn't just a force, it's the curvature of space and time. This warping happens around anything with mass, right? And the theoretical leap is that if you have enough mass and you get it in just the right configuration, you could warp space-time so much that you create a fold. It's like folding a piece of paper. Those two distant points on the paper are suddenly right next to each other, and boom, a wormhole. A shortcut, not just across space, but potentially time, too.
That's wild. So who first came up with this crazy idea of bending space-time?
Well, the history is pretty cool. It was actually Ludwig Flamm, an Austrian physicist, back in 1916, right after Einstein published his theory of general relativity.
Wow, so it's been around for a while, but the source says opening one of these things would take like a ridiculous amount of energy.
Oh yeah, that's a big problem. Michio Kaku, he's a pretty well-known physicist, he suggested you'd need the energy of an entire galaxy.
A whole galaxy. Jeez. So even if it's possible in theory, practically speaking.
It might be a bit beyond us, at least for now. And there are other issues too. You mentioned paradoxes earlier.
Right. Going back and like accidentally preventing yourself from being born. But yeah, the energy problem seems like a bigger hurdle right now.
Yeah, for sure.
The source does mention this thing called negative mass.
Right, negative mass. This is where it gets really weird. It's this hypothetical stuff, right? With gravity that works in reverse. So it'd be repelled by gravity instead of being attracted to it.
Okay, wait. It's not just energy we're talking about here. It's like actual stuff that has anti-gravity.
Exactly. And the idea is, if this negative mass exists, maybe, just maybe, it could provide the kind of exotic energy you need to hold a wormhole open, keep it from collapsing in on itself.
That's mind-blowing. I'm trying to picture it. But, you know, the source also throws out another possibility, zero-point energy.
Oh yeah, that's another really intriguing one. It's all about this immense energy that theoretically exists everywhere, even in totally empty space, a vacuum.
So, like, tapping into the energy of nothingness.
Exactly. It's all very theoretical. But if we could somehow harness that, it might be another way to create and, more importantly, stabilize a wormhole.
Okay, we keep saying wormhole, but I've also heard the term Einstein-Rosen bridge.
Oh yeah, that's the more technical term.
So where did the whole wormhole thing come from?
That was John Wheeler, another brilliant physicist.
Oh.
Back in the 50s, he thought wormhole was just, a better image. It's like a worm burrowing through an apple.
I get it. Like creating a shortcut through space-time, it's much easier to picture than an Einstein-Rosen bridge.
Exactly. And speaking of pictures, we often see wormholes in movies and TV as these, like, tunnels, right? But the source says that's actually misleading.
Oh, interesting. So not like a cosmic tube.
Nope. That's just us trying to visualize a higher dimensional thing in our 3D world. Remember, space-time is more like this fabric, right? So a wormhole is more like a fold in that fabric where two points are brought together.
Okay. So not a tunnel, but a fold. Got it.
Think about Interstellar. That movie did a pretty good job.
Oh, yeah. That weird sphere, like looking through rippling water.
Exactly. That's a much better representation. It'd be like a convex 3D object. The light from the other side would be all bent and distorted, making it seem like a surface. But as you get closer, that surface would just disappear, and you'd transition to the other side seamlessly.
No swirling vortex or anything?
No, nothing like that.
That's trippy. And the source also says that wormholes might not be permanent. They could just like pop in and out of existence.
Yeah, some astronomers think that naturally occurring wormholes, if they even exist, would be super unstable. They might fluctuate in size and only last for a very short time.
Kind of like those time portals and time bandits. They're all over the place, and you got to be in the right place at the right time to jump through.
Right, exactly. Fleeting windows in time, basically.
So big, unstable wormholes for cosmic travel. But then the source goes to the other extreme and talks about tiny wormholes.
Oh yeah, this is where it gets really wild. Some physicists think that these tiny, microscopic Einstein-Rosen bridges might be the reason for something we know is real. Quantum entanglement.
Quantum entanglement. That's when two particles are linked, even if they're light years apart.
Exactly. And some think these tiny wormholes might be what connects them, making them act like a single unit. It's like a fundamental interconnectedness between everything, blurring the lines between space and time.
That's mind-blowing. So these tiny wormholes, they're not just a theoretical curiosity.
Right. They might be the key to some pretty crazy stuff. Like, imagine sending a single molecule, or even a virus, back in time to a very specific point, maybe even into a living organism.
Like microscopic time travel surgery. The source calls it history gardening, which I kind of love.
Yeah, it's a great term.
Okay, so that's wormholes, from the huge and unstable to the tiny and potentially world-changing. But now, the source moves on to a different concept, timeships. What makes them different?
Well, unlike wormholes, which are like existing shortcuts, Timeships would be vehicles that let you, the traveler, basically occupy a different time zone than everyone else.
Okay, that sounds a lot like H.G. Wells' The Time Machine. You know, that image of the machine sitting still while time whizzes by outside?
Exactly. Wells' idea is more like suspended animation for the time traveler. They stay in their present while everything else around them speeds up or slows down.
So their past is just the machine sitting there getting older. I remember the source mentioning Minkowski and world lines here.
Right, world lines. Herman Minkowski had this idea that objects aren't just points in space. They trace these paths, these world lines, through the four dimensions of space-time. So the time machine's world line is its whole history, existing in a specific place over time.
Okay, I think I'm following. But the source says that real-time travel in a timeship would need more than just experiencing time at a different rate, right? Like actually moving through space as well.
That's a key point. Remember how faster than light travel is theoretically the same as time travel? Well, if you could go faster than light, you could basically outrun causality, move back in time relative to everyone else.
Which brings us to the Alcubierre warp drive.
The warp drive, that's a classic.
It's all about warping space-time, right? To like surf a wave faster than light.
Exactly. Imagine contracting space-time in front of your ship and expanding it behind you.
Yeah.
You create this warp bubble where you could theoretically go faster than light without actually breaking the speed limit inside the bubble.
Okay, that's trippy. But wouldn't that lead to all sorts of paradoxes? The source kind of dismisses those concerns, even mentioning Stephen Hawking's chronology protection conjecture.
Yeah, the source definitely has a different take on causality violations. It seems to think those paradoxes might not be the deal breakers people think they are.
So going back in time and meeting your younger self, it wouldn't necessarily unravel the universe.
The source seems to think it would just be, part of the timeline, maybe even part of a secret history we haven't uncovered yet.
Okay, so maybe the universe is a little more flexible than we give it credit for. But moving on, the source talks about true timeships, based on work by Tippett and Singh. How do these timeships actually work?
They propose that a true timeship would basically create a bubble of space-time around itself, like an isolation field. And this bubble would be completely detached from the normal flow of time outside.
Like a time bubble.
Yeah, exactly. This would let the timeship not just travel through space, but reverse its direction along the time axis, like a U-turn.
Whoa, a U-turn in time. That's wild. The source mentions metamaterials?
Right, metamaterials are like engineered materials with properties we don't find in nature. Maybe they could manipulate electromagnetic fields or even space-time itself to create and maintain that time bubble.
So what would it be like to be inside that bubble, moving backwards in time?
Weirdly, you wouldn't actually experience time flowing backwards. Instead, you'd see everything outside moving in reverse. Imagine someone watching you from outside the bubble. They might see two identical timeships appear, collide, and then vanish. It's the same ship, just moving in opposite directions in time.
Like a time-traveling twin. The source even compares it to that scene in Yellow Submarine where the Beatles meet another version of their submarine going backwards in time.
Right. The source says there should actually be 3 versions, if you think about it, which is kind of hilarious.
So one time ship zipping back and forth in time could look like a whole fleet.
Exactly. But what about actually seeing the outside world while you're moving backwards in time? Would it be like everything in rewind?
Yeah, that's what I was thinking.
The source brings up this really interesting point. Think about how we see light from objects travels to our eyes, right? Well, if you're moving backwards in time, those photons are going the wrong way away from you.
Ah, so the world outside might actually look dark, like a void.
That's the idea. Kind of spooky, right?
Totally. But the source mentions a possible solution, tachyons.
Tachyons, yes. They're these hypothetical particles, faster than light, that naturally move backwards in time.
Hold on, faster than light.
That's the theory. So maybe a timeship could have like a special view screen that detects these tachyons and translates them into visible light. Then you could actually see the past unwinding around you.
Tachyon's special view screen. This is getting pretty sci-fi. But the source makes this crazy connection to Hal Puthoff and the Stargate program.
Right. Apparently, Puthoff's research into things like tachyons, even though it was super theoretical, played a role in him getting involved in parapsychology and the whole remote viewing thing.
Wow, you never know where scientific curiosity will lead you. Okay, so time ships might be able to make these U-turns in time, but what happens if they're doing it constantly, flipping back and forth?
Well, the source says that could create the illusion of multiple objects appearing and merging. One time ship could look like a whole swarm, splitting and rejoining.
That sounds familiar. A lot of UFO reports talk about objects doing exactly that, appearing and disappearing, merging and splitting.
Exactly. Maybe that's what we're seeing. A single time ship shifting through time.
That's really interesting. And maybe this explains how they seem to move so fast and do impossible maneuvers.
It's possible. If they're manipulating space-time around them, they could basically teleport from one point to another, from our perspective.
And what about those tic-tac UFOs the Navy pilots encountered? I remember the source mentions Jack Sarfati and his theory about them.
Yeah, Sarfati thinks those tic-tacs might be made of these advanced metamaterials, maybe even something that can slow down light locally. And guess what? He also thinks they could be time machines from the future.
So not just bending space-time, but like changing the speed of light itself.
That's the idea. Pretty wild stuff.
Okay, so we've got wormholes, time ships, maybe even manipulating the speed of light. And all of this might be connected to UFOs.
That's what the source is suggesting. It's a big leap, but it's definitely thought-provoking.
It is. And the source isn't the first to make this connection. It mentions Jacques Vallée.
Oh yeah, Valley's a legend in UFO research. In his book, Passport to Magonia, he suggests that UFOs might not be alien spacecraft at all, but projections from another time. Maybe even like 3D holograms with mass, projected through time.
Holograms from the future. That's even weirder than aliens.
Right. And if future humans have time travel, maybe they're choosing to interact with us in a more subtle way.
Yeah.
Using wormholes to observe us.
Kind of like how we might watch an ant farm.
Exactly. Or like tending a garden, making small adjustments to steer things in a certain direction. The source calls it history gardening.
I like that. History gardening. So we could be part of some giant experiment orchestrated by our descendants. That's kind of creepy, but also kind of cool.
Yeah, definitely both.
The source then brings up Michael Masters and his extratempestrial model. What's his take on all this?
Masters argues that the idea of time travelers is actually more scientifically plausible than aliens. One of his big points is the way UFO occupants are always described, as human-like.
Right, the grays and all that. But if they really were aliens from another planet, wouldn't they look totally different from us?
Exactly. But Masters goes further. He focuses on specific details like their small stature, big heads, large eyes. And he says those features actually match trends in human evolution, like paedomorphosis.
Paedomorphosis? Isn't that when adult descendants retain juvenile features?
That's it. Like humans compared to chimps. We have flatter faces and bigger heads relative to our body size, kind of like baby chimps.
So Masters is saying that maybe these aliens aren't aliens at all. They're just future humans who've evolved to look more childlike.
That's his theory. And it would explain why they look so familiar, even if they seem a bit, off.
That's a really interesting perspective. And what about those crazy speeds and maneuvers UFOs are always pulling off?
Yeah, defying gravity, making instant turns at supersonic speeds, all that. The source ties that back to what we were talking about before, manipulating space-time around the craft.
Like using a warp drive or creating a time bubble.
Exactly. It's like they're not bound by the same rules of physics that we are.
Makes sense. And remember that entry in Wernher von Braun's diary?
The one about seeing those weird orbs during the Trinity nuclear test.
Yeah. The source suggests it could have been a time traveler, checking out that pivotal moment from different points in time.
That's a cool thought. Maybe all these UFO sightings, even the ones that seem contradictory, actually make sense if we think about time travel.
Like, we're only seeing glimpses of a much bigger four-dimensional reality, what the source calls tesseractuality.
Exactly. We're like stuck in our 3D world, trying to make sense of something that exists on a whole other level.
Okay, so buckle up, because the source takes this a step further and suggests that some UFOs might not even be vehicles. They might be wormholes themselves.
Whoa, that's a new one. So not a ship going through a wormhole, but the UFO is the wormhole.
That's the idea. And it would make sense if we think about how different a lab-created wormhole might look compared to, say, the one in Interstellar.
Right, in Interstellar, you see through it to another galaxy. But if you created a wormhole in a lab, you'd be looking into the machine itself, kind of inside out.
So that classic flying saucer shape, maybe that's just us seeing the inside of a wormhole generator.
Exactly, and the aliens inside. Maybe they're just technicians or scientists on the other side.
And that would explain why some abductees describe these crazy interiors bigger on the inside than the outside, right?
Right, and weird layouts that don't make sense for a conventional spaceship. It's all about perception, seeing a 4D object from our limited 3D perspective.
That's amazing. It's like a whole new way of looking at UFO sightings. But what about all the energy these UFOs seem to use?
Well, if the UFO is a wormhole, The power source could be somewhere else entirely, back in the future where it was created. The UFO itself wouldn't need to carry all that energy around.
That makes sense. Okay, so this brings us to a big question. If time travel is really possible, why aren't we seeing tourists from the future everywhere?
Stephen Hawking, he famously pointed this out, like, where are all the time travelers? But you know what? The source actually addresses this head on.
Oh, good. I was hoping it would. What does it say?
It calls Hawking's question, and I'm quoting Michael Masters here, myopic and presumptuous.
Whoa. Strong words.
But it makes a good point. It compares Hawking's argument to the Fermi paradox. Where are all the aliens? Well, UFO sightings were already happening when Fermi asked that question.
So just because we haven't met any card-carrying time travelers...
Doesn't mean they're not here, maybe just not in a way we recognize.
Right. If we don't even understand how time travel works, how would we know what to look for?
Exactly. We're limited by our current understanding of the universe.
And the source even brings up the Bible. No time travelers in the Gospels, right?
That's what it says, but then it points out that the Bible is full of other weird stuff. Angels, the Star of Bethlehem, mysterious visitors appearing out of nowhere.
So maybe some of those figures, or even some of Jesus's followers, were time travelers, just disguised within the context of their time.
It's definitely an interesting possibility. And it leads to what the source calls a duh moment. Maybe time travelers are all around us. We just haven't been able to see them because we're thinking about time in such a linear way.
Like a total shift in perspective. Wow, this is heady stuff.
It is. But remember, just because we start thinking about time travel doesn't mean the past itself changes.
Right. It just changes how we understand it. And to be fair, we've only recorded a tiny fraction of everything that's ever happened.
Exactly. There are huge gaps in our knowledge of history.
So maybe we should be a bit more humble about what we think we know. If time travel is real, our whole understanding of history could be incomplete, to say the least.
Absolutely. It's a good reminder that history isn't a fixed story. It's a collection of perspectives that changes as we learn more.
Okay, so let's say future humans are visiting the past through wormholes or timeships or whatever. What's their motivation?
That's the big question, right?
Yeah.
And the source suggests it probably isn't about changing the past.
Yeah, we talked about how that might be impossible, or at least super difficult. So what's the point of going back then?
The source thinks it's all about knowledge.
Knowledge? Like what? Going back to take notes for a history book?
Maybe, but it's probably bigger than that. Think about filling in the gaps in our understanding of the past, learning about our origins, unraveling the mysteries of the universe.
So even if you can't change the past, you can learn from it.
Exactly. The source even brings up this short story by Ted Chiang called The Merchant and the Alchemist's Gate. The main character travels back in time, but he can't change anything. What he does get is knowledge, closure, a deeper understanding of his past.
So even without changing events, the knowledge itself can be transformative.
It can bring peace, understanding, maybe even a sense of redemption.
Wow, that's powerful.
So, sometimes I find it pretty amazing how some of the most futuristic-sounding ideas actually end up having these really deep connections to, well, ancient wisdom.
That's so true.
Like you think about, something like time travel, which sounds totally sci-fi.
Right.
But then you start digging into it, and you realize that, well, maybe our ancestors, even thousands of years ago, already had some of the conceptual tools to grapple with that kind of thinking.
Yeah, absolutely. Like they were already masters of navigation in a way that we've kind of lost touch with, with GPS and all that.
Exactly. And our listeners, well, they're here because they get that. They're driven by that curiosity, that desire to understand these complex ideas, but without getting lost in the weeds. So right from the start, what really struck me in the source material was this idea that time, this fourth dimension, might not be just this linear progression, but it might have its own shape, its own structure, almost like a landscape.
Yeah, that's really fascinating, isn't it? Like the source even suggests that the past and the future might not just be this straight line, this arrow of time that we often think about, but more like a vast ocean with its own kind of, depths and shallows, maybe even some storms to navigate around.
I love that analogy. Like navigating time might not be about simply choosing a date, but more like traversing this complex temporal seascape, right?
Exactly. And you have to know how to read the currents, the winds, the stars to find your way.
And that brings us to this remarkable parallel that the source draws between between this whole concept of temporal navigation and something that that might seem completely unrelated at first, but is actually incredibly relevant, the art of Polynesian wayfinding.
Okay, I'm intrigued. Tell me more about this.
So imagine this. Thousands of years ago, Polynesian navigators were undertaking these epic voyages across the Pacific Ocean.
I mean, we're talking vast distances, right?
Huge, absolutely huge. And they were populating these massive stretches of the Pacific, all without any of the modern instruments that we take for granted today. No GPS, no satellites, and crucially, no accurate way to determine longitude until much, much later.
Yeah, longitude was a huge problem for early navigators everywhere. You need a very accurate clock for that, and those weren't exactly readily available back then.
Right. It wasn't until, I think it was the 18th century that they really figured out how to solve that problem with a reliable marine chronometer.
So these Polynesian navigators, they were doing this incredible stuff centuries, even millennia before that. How is that even possible?
Well, that's the amazing part. These voyages weren't just random driftings.
Okay.
The Polynesians, they had this astonishingly precise knowledge of where they were going, how to get there. It's mind-blowing when you think about it.
I mean, finding tiny islands in this vast expanse of ocean, that's like finding a needle in a haystack.
Exactly. It's
What?
a level of skill and observation that's almost unimaginable for us today. You know, we can just punch an address into our GPS and boom, we're there.
We've lost that connection to the natural world that they had.
For sure. And their methods were so intricate. They were reading the wind, the sky. They had this deep understanding of the stars.
Like, how many stars did they know?
Oh, countless. And not just individually, but as these directional lines across the sky. And they knew how to use the stars to determine their latitude.
Oh.
But it wasn't just about the heavens. They also had this incredible connection to the ocean itself. They could read the patterns of the waves, how they bent around islands that were miles away.
They could tell there was land just from the waves.
They could. They could also see tiny changes in the color of the water, indicating different depths or currents. They even observed the flight paths of certain birds, which could lead them to land.
So they were basically putting together this whole mental map based on all these tiny little clues.
Exactly. And all this knowledge, this incredible body of navigational lore, it wasn't written down in charts or maps. It was passed down through generations, orally, in songs, stories, practical demonstrations.
That's incredible. So they had this living tradition of navigation.
Yeah. And the source even talks about this guy named Nainoa Thompson. He's a modern-day navigator who actually reconstructed these ancient techniques at the Bishop Museum Planetarium. And he was able to sail between Hawaii and Tahiti using only those traditional methods.
Wow. So it's not just theory. It actually works.
It totally works. And that's where the connection to temporal navigation comes in. Because just like those Polynesian navigators, time travelers would need to be incredibly attuned to these subtle environmental cues.
They'd have to read the currents of space-time, so to speak.
Exactly. The source suggests that instead of having fixed coordinates, they'd have to interpret these different clocks that are operating throughout the universe. Things like the rotation of planets, the pulsars, even the expansion of the universe itself.
So instead of a GPS, they'd need a cosmic chronometer.
I like that. And just as spatial navigators need to understand ocean currents and celestial movements, a time traveler would need to be able to perceive and interpret these temporal currents, maybe even distortions in the timeline itself.
Okay, so we've got this analogy of time as an ocean with its own currents and eddies, but how do you actually navigate it? How do you find a specific location in time, like a specific date?
Right. That's the million-dollar question, or maybe the billion-year question in this case. Unlike spatial coordinates, latitude and longitude, time doesn't have these obvious markers, these date stamps built into it.
We're so used to seeing in movies and TV shows, right? They just set the date on their time machine and off they go.
Right. Like in Star Trek or Back to the Future.
That seems so easy. Just punch in the date and boom, you're there.
But the source material really digs into why it's actually way, way more complicated than that. It even references Kirk and Spock in that classic Star Trek episode, The City on the Edge of Forever, where they slightly overshoot their target.
Oh, yeah, I remember that episode. They end up in the wrong time period and things get pretty messy.
Exactly. And that's the point. Even in fiction, there's this recognition that temporal navigation can be imprecise, even dangerous.
Okay, so no setting a dial on a time machine. What does the source suggest would be involved in actual time travel?
Well, the first big hurdle, and this might come as a surprise, is that time travel probably can't happen without space travel.
Really? So you can't just jump in time from where you are?
Probably not. The source gets pretty technical here, talking about the need to bend your light cone. But basically, it means you might need to travel at incredibly high speeds, maybe even faster than light, to shift your position in time.
Okay, so we're talking interstellar voyages just to get started.
It seems likely, especially if you were to use something like the theoretical Alcubierre warp drive.
The warp drive, I've heard of that. It's that thing where you warp space around your ship to travel faster than light, right?
Exactly. It's like creating a bubble in space-time that allows you to kind of cheat the cosmic speed limit. But even if you could achieve that, even if you could travel across the galaxy, the problem of pinpointing a specific moment in time still remains.
So you've made this incredible journey across space, and now you have to figure out where you are in time?
Yeah. It's like, imagine sailing across the ocean without a compass or a map, and then having to figure out exactly where you've landed on the coast.
That's a great analogy. So how would a time traveler even begin to orient themselves?
Well, the source suggests that for relatively recent time periods, like, say, the industrial era, there might be some terrestrial clues to help.
Okay, like what?
You could try landing near a populated area, and, well, assuming you could understand the language, you could check a newspaper or a calendar to get a sense of the date.
Right, or maybe listen to the radio.
Exactly. Or the source even mentions using artificial intelligence, maybe sending out a small drone to do some reconnaissance.
Okay, so that's for the recent past. But what about going further back to before we had newspapers and radio?
Now that's where things get really tricky. Before widespread industrialization and easily datable records, an astronomical computer would become absolutely essential.
An astronomical computer, like a really, really old school computer.
Not exactly old school, but definitely using principles of astronomy to calculate the date based on the positions of the stars and planets.
Oh, I see. So it would be like those ancient astronomers who could tell the time and date just by looking at the sky.
Precisely. But it would have to be incredibly precise, able to account for all the tiny variations in the movements of celestial bodies over long periods.
That sounds incredibly complicated.
It definitely is.
Yep.
And even if you could theoretically pinpoint a year, a month, and a day based on those calculations, finding a specific historical event would still be a huge challenge.
Right, because history isn't always so neat and tidy, is it?
Definitely not. The source makes this really interesting point about how our chronological frameworks, especially for ancient times, are often more like a constructed narrative.
Yeah, we're piecing together the past from fragments of information, often written long after the events themselves.
Exactly. And there's always room for interpretation, debate, even revisionism. The source even mentions some pretty radical historical theories out there, like the idea that whole centuries of history might have been fabricated or misdated.
Wow, so even if you could travel back in time, finding a specific event like, say, the signing of the Declaration of Independence or the fall of the Roman Empire might be nearly impossible.
It might be. And that brings us to another intriguing idea that the source explores. What if some of the UFOs that have been reported throughout history aren't alien spacecraft at all, but rather time travelers who have gotten lost?
Time travelers who are lost in time. That's a really interesting thought.
Right. The source calls them lost chrononauts. And if temporal navigation is as difficult as we've been discussing, then it makes sense that some time travelers might end up, well, of course.
Yeah, instead of a precise landing, they might end up bouncing around the timeline, appearing in different places and times seemingly at random.
Exactly. And that they could explain why UFO sightings are often so bizarre and unpredictable. It's not necessarily that aliens are trying to be mysterious, but maybe they're just as confused as we are.
I like that idea. It kind of humanizes the UFO phenomenon in a way.
Yeah, it does. And it ties in with some of the theories about UFOs and their potential influence on human history and mythology.
Okay, how so?
Well, the source mentions Jacques Vallée, who's a well-known UFO researcher. He has this idea called the control system hypothesis.
The control system, what's that?
It's the idea that the intelligence behind the UFO phenomenon might be subtly influencing the development of human civilization, kind of nudging us in certain directions.
Okay, but if these are time travelers who are lost, how would they be able to control anything?
That's a good question. Maybe it's not intentional control, but more like unintended consequences. Imagine a time traveler accidentally appearing in the middle of uh, a religious ceremony or a political upheaval.
That could definitely have some ripple effects.
Right. And maybe those ripple effects are what Valley is picking up on as this control system.
Yeah, I see. So it's not about intentional manipulation, but more about the inherent chaos of time travel.
Yeah, and the source also touches on this emerging idea that UFOs might have a religious or spiritual dimension.
Okay, I've heard about that. Some people believe that UFO encounters are actually religious experiences.
Right, but the source flips that idea on its head a bit. It suggests that maybe it's not the witnesses who are having the religious experience, but the time travelers themselves.
Okay, that's interesting. So they're not coming here to study us, but maybe to connect with their own past, their own spiritual heritage.
Exactly. The source uses this great analogy from a novel called A Maggot by John Fowles.
I haven't read that one. What's it about?
It's about these future religious pilgrims who travel back to the 18th century to meet an ancestor, the mother of Anne Lee, the founder of the Shakers.
Oh, wow. So they're going back in time to connect with their religious roots?
Precisely. And the encounter is, well, it's incredibly confusing for the people in the past. They interpret it through their own 18th century religious framework.
Right, because they have no context for what you're seeing.
Exactly. But for the time travelers, it's this incredibly meaningful spiritual experience. And the source even speculates that the 18th century might be the earliest point in time where targeting specific individuals like religious figures or ancestors becomes feasible, because of the more detailed historical records that we have.
So maybe those time travelers are out there searching for their own personal connections to the past.
Maybe they are. And the source even goes so far as to suggest that the biblical story of the three wise men, the Magi, could be interpreted as a time travel encounter.
The three wise men as time travelers, how so?
Well, they followed a star to find Jesus, right? What if that star was actually some kind of advanced AI, maybe a drone, guiding them through time?
That's a pretty wild interpretation.
It is. But it's those kinds of out-of-the-box ideas that can really help us to see these old stories in a new light. The source even mentions this guy, Jim Penniston, who claims to have had an encounter with the UFO at Rendlesham Forest. Under hypnosis, he described the occupants of the craft as time travelers from the future who could only travel within a limited range of like 40 to 50,000 years.
Interesting.
And get this, they were supposedly on a mission to collect genetic material because of future reproductive problems.
Wow. That's definitely a specific reason for traveling through time.
Right. It kind of reinforces this idea that even if time travel is possible, it might not be as easy or as glamorous as we often imagine. These travelers might be struggling with limited technology, navigational challenges, all sorts of unforeseen consequences.
So we've talked about the challenges of using what we might call timeships, individual vessels navigating the temporal currents. But the source then introduces an even more mind-blowing concept: the potential for wormhole networks.
Wormholes, like those theoretical tunnels through space-time?
Exactly. It takes us beyond those individual time travel journeys and into the realm of creating permanent, or at least semi-permanent, gateways between different points in time.
So instead of just hopping in a time ship and trying to navigate to a specific date, you could potentially step through a wormhole and arrive, well, pretty much instantly at your destination.
Yeah, it'd be like having a temporal subway system. You just get on at one station and get off at another, no matter how far apart they are in time.
I love that analogy.
Yeah.
So how would these wormhole networks even be possible?
Well, the source gets into some pretty heavy physics here, but essentially it involves manipulating the mouths of wormholes, possibly using the immense gravity of a black hole.
The black holes, those things that are so dense that not even light can escape them.
Yep, those are the ones. The idea is that you could potentially create a wormhole by distorting space-time around a black hole and then, well, somehow move the mouths of the wormhole to different locations in time.
But wouldn't that be incredibly dangerous? I mean, getting anywhere near a black hole sounds like a recipe for disaster.
It definitely wouldn't be a walk in the park. But remember, we're talking about theoretical possibilities here, about what might be achievable in a highly advanced future civilization.
Okay, so let's say, just for the sake of argument, that it is possible to create these wormhole networks. What would be the advantages over using time ships?
Oh, the advantages would be enormous. For one thing, it would make time travel far more efficient and reliable.
No more getting lost in the temporal currents.
Exactly. You wouldn't need to worry about calculating precise trajectories or dealing with the inherent uncertainties of navigating through time. You could just step through a wormhole and arrive exactly where and when you want it to be.
That would be incredible. And the source even suggests that these wormholes could be used for more than just transporting people.
Oh, right. It talks about the possibility of sending materials and even energy through time.
Imagine that. You could send supplies or equipment to the past, or maybe even bring back resources from the future.
It would completely revolutionize how we think about time and our relationship to it. The source also mentions the potential for remotely controlling devices in the past from the future.
Like time-traveling drones.
Exactly. You could send a drone through a wormhole to explore a particular time period and then control it from the present.
That would be amazing for research, for archaeology, for understanding history.
Absolutely. It opens up a whole new world of possibilities.
And speaking of exploring the past, the source also revisits this idea that time travel, even if it's unintentional, could have a profound impact on our understanding of history and mythology.
Right. We talked about that earlier with the control system hypothesis and the idea of lost chrononauts.
And this is where it gets really philosophical because it raises questions about, well, about free will and the nature of causality. If someone from the future can travel to the past, can they change it? And if they can change it, does that mean that our present is predetermined?
That's a huge question. I mean, it gets to the heart of what it means to be human, to make choices, to have agency in our own lives.
The source talks about this idea called the Novikov self-consistency principle, which essentially says that the past is, well, in a way, fixed.
Fixed, so you can't change it.
It's more complicated than that. The principle suggests that the timeline has a kind of built-in resistance to paradoxes.
Paradoxes, like the classic grandfather paradox, where you go back in time and accidentally kill your own grandfather.
Exactly. The Novikov principle says that something would always prevent those kinds of paradoxes from happening.
So you could travel to the past, but you wouldn't be able to change anything that would fundamentally alter the present.
That's the idea. It's like trying to change the course of a river. You might be able to create some ripples, but you can't make it flow uphill.
So even if time travelers are out there, maybe they're not as free to interfere with the past as we might think.
Maybe not. But their very presence, even if it's unintentional, could still have a huge impact.
Right, because as we talked about before, their actions, even accidental ones, could be misinterpreted and woven into our myths and legends.
Imagine, for example, a time traveler appearing in the middle of a battle in ancient Rome.
People would be terrified. They wouldn't understand what they were seeing.
Exactly. And that event could easily become part of their mythology, their stories about gods and monsters.
So some of our most enduring myths could be based on real encounters with time travelers, but distorted through the lens of the past.
It's a fascinating possibility, and it really makes you wonder how much of what we think we know about history is actually true, and how much of it is, embellished or misconstrued over time.
It's like suddenly all of history becomes a giant question mark.
It kind of does, and that brings us to the end of our deep dive into the mysteries of temporal navigation. It's been a long journey, but hopefully an enlightening one.
It certainly has. We've covered a lot of ground, from the ancient Polynesians to wormhole networks to the possibility that UFOs are actually lost time travelers.
And we've explored some really profound questions about the nature of time, free will, and the very fabric of reality.
It's enough to make your head spin.
But in a good way, I hope. So as we wrap up, I want to leave you with this final thought. If time travel is indeed possible, and if future civilizations have mastered the art of navigating through time, even imperfectly, how many of our historical mysteries, those unsolved puzzles and strange events that have baffled us for centuries, might actually be echoes of their journeys?
It's a question that could keep us pondering for a long time.
It definitely could. And that's what makes these deep dives so rewarding. They challenge our assumptions, expand our horizons, and remind us that there's always more to learn, more to explore, more to discover.
And who knows, maybe one day we'll be the ones traveling through time, leaving our own echoes in the past.
I like that thought. So if you enjoyed this exploration into the intricacies of temporal navigation, be sure to like and subscribe for more voyages into the fascinating and often unexpected realms of knowledge.
And until next time, this has been Teolumen Insights.